All right, you guys, we're just going for it. So here we are, section 6.4, part 2, where we're still applying the chain rule and we're still thinking about that like inside-outside composition of function thing, and we're taking the derivative by applying the chain rule. So in words, one more time, remember the chain rule is the derivative of the outside, leaving the inside unchanged, times the derivative of the inside. So really, now that you kind of have like the notation down and how it goes, it's more just about seeing lots of examples, getting lots of practice, and seeing how the algebra gets finished out. Because that tends to be more of the mistakes really than like the calculus. So the directions say to differentiate the following, and we have for number 1, u of x in function notation, which is nice. We like it when we have function notation because we can usually go straight to the primes when we take the derivative, equals 1 over the whole quantity, 1 minus x squared to the third power. So do you see how we have this like inside piece and it's being raised to the power? But that doesn't really seem to apply straight to power rule, because then we think about power rule, it's usually whatever the quantity or the variable is on the top raised to a power, and this is like on the bottom. But we can kind of, again, change our original function u of x to make it more calculus friendly. Like how we do with square roots when we change something into the 1/2 power. I'm not taking the derivative yet. I'm not finding u prime yet. I'm just manipulating the original u function so it is in a more calculus friendly form. So the way that I'm going to do that is I'm going to think, well, if this whole quantity is to the third power in the denominator, then using rules of exponents, kind of the backwards way, couldn't I flip this whole quantity up top and change it into the negative third power? If I move its position, that changes the exponent from a positive to a negative. And if it's already in the denominator, I don't want to move it to the top. Well, the 1 up top, I don't need to keep. 1 times anything would just stay itself. So it's 1 minus x squared, the whole thing to the negative third. So we have this inside piece, the 1 minus x squared, and the outside piece is that it's raised to the power negative third. So this is a chain rule problem. It is a composition of functions, and we're going to take the derivative using the chain rule. So now that I'm in this more calculus-friendly form, now I'm ready for this notation, because I am taking the derivative of both sides with respect to x. So u of x turns into u prime of x, the derivative of u with respect to x. It equals, say it out loud, the derivative of the outside. Okay, the outside's the whole negative third power, so bring that power down in front. We leave this inside unchanged. We decrease the power by 1. Negative 3 minus 1 would turn into negative 4, right? So this whole inside just remains the same and plops down in here. But that's not it for chain rule, because we have to multiply by the derivative of the inside. So if we just take it term by term, the derivative of the inside, it's just individual terms, one right after the next, just power rule it through. The derivative of the constant 1 is going to go to the 0. The derivative of a negative x squared, this is like a negative 1 coefficient. When the 2 come down with the negative 1, they would multiply to give me negative 2 times x, the x wouldn't change, and I would decrease the power by 1. So x squared, when I do 2 minus 1, would turn into just x to the first power, which a lot of you aren't going to write. I'm just writing on this step for like extra exaggeration. And because this is only one term, I don't need any sort of extra grouping symbols. If my derivative of my inside had been more than one term, I absolutely would have to have parentheses or some sort of grouping symbol to say it's multiplied with all of those terms. But if it's only one term, you don't need any grouping symbols. So there's the calculus step. And now we're ready to do some algebra cleanup. So I'm still working with my derivative, but we know we don't want a final answer with negative exponents, so we definitely got to take care of that. And we maybe need to see if anything cleans up, or maybe kind of put all of this together as one big final answer. So there's lots of ways to think about it. This negative 3 is a negative number, not a negative exponent, right? It's negative 3 over 1. This is a whole quantity to the negative fourth. They're squashed together. When things are squashed together, math means to multiply. That whole quantity is over a 1. This is a negative 2x. I don't really need x to the first. It's over 1. So if you want to think about them all as, hey, they're individual fractions all multiplied together, clean up each individual fraction, maybe that will help. So this negative 3 would remain up top in the numerator. Wouldn't this, because it's a quantity to a negative fourth, have to flip down into my denominator? The inside doesn't change. That's the base. But now that instead of being raised to the negative fourth, it would be to the positive fourth power. Multiplied with the negative 2x, that's a negative constant, a negative coefficient in front. That's not a negative exponent. It stays on top. And then wouldn't the negative 3 times the negative 2 turn into positive 6, the x would still be with it, over the whole quantity 1 minus x squared, the whole thing to the 4th power. Denominators we leave in factored form. I'm not really going to write that out 4 times in a row and multiply it by itself 4 times in a row. This is exactly what we're looking for. Okay? So there's example number 1.
All right, next one. Say d dx of 1 over the square roots of x squared plus 8x. All right, so what I want to do here is you could do the chain rule or the quotient rule, do low d high. Okay, but I would just flip this and make it one fraction. I don't know what I'm saying right now. Basically, what I'm trying to say is this is really d dx of 1 over x squared plus 8x to the 1/2 power. I can then bring that up to the top and get rid of my fraction by saying to the negative 1/2 power. So here I got d dx of x squared plus 8x now to the negative 1/2.
So these are really the same problem. I mean, slightly different, because this has our rational exponent instead of a whole number, but it was a whole quantity to a power on the denominator with just a constant on top. Can't you just move it up and make it a negative exponent? We're just trying to show you that, but we're using different notations too. Trying to get you used to that notation.
Okay, like I said, I haven't changed this really at all. It just algebraically looks a little bit differently. That's why I had to write d dx every single time, because I haven't actually taken the derivative yet. Okay, so now in this step, I'm going to take the derivative. I bring my negative 1/2 out front. Okay, subtract 1 from my exponents. Now negative 1/2 minus 1 is going to be negative 3/2.
Mr. Herner, you better say that one more time. What just happened? Negative 1/2.
So we have negative 1/2.
We decrease the power by 1.
We're subtracting 1, which is really minus 1 over 1, or 2 over 2. So negative 1/2 minus 2/2 is going to make negative 3/2.
Oh, you can't screw up subtracting fractions.
Okay, so like I said, our inside is then going to stay the same. So we copy that part down. Times the derivative of the inside. So derivative of x squared is going to be 2x. The derivative of 8x is just going to be 8. So plus 8. Remember your parentheses. Okay, then we're just going to try to clean it up. Like one more time here, like this is where I took the derivative. I don't write d dx anymore. I'm all done with it. Okay, here I took the derivative with respect to x and got this. Alright, so I've got negative 1 over 2. So I put the 2 on bottom, put the negative 1 on top. This is a negative exponent. I'm going to bring that guy down to the bottom. It's going to become x squared plus 8x to the positive 3 over 2. Okay, then up top I still have 2x plus 8. Okay, so a lot of people are going to want to write 2x plus 8. Okay, and just say, oh yeah, we had that negative and this is now wrong. Okay, it's going to be negative 1 times all of that. So this needs to be in parentheses. I would like you to clean it up a little bit from there. This is going to be one of the times when you can't really write your answer in the same form that you started with either. Okay? So, another thing I would like you guys to see is this is to the exponent of 1. Okay, so you can take a 2 out of it. Now, if that was to a different exponent, we don't want you messing with this. But I could factor a 2 out. Now I have negative 2 times x plus 4 all over 2 times x squared plus 8x to 3/2. And my 2's will then cancel because that 2 is being multiplied by everything else on top. And that 2 is being multiplied by everything else on bottom. So you can slice those up and we're left with negative x plus 4 and x squared plus 8x to the 3/2 power. Hopefully you recognize that this is bad because it was negative times both of these, and you'd have to have negative x minus 4, or you would need that x plus 4 in parentheses. Alright?
Good.
Another thing, let's say there was no 2 down here, then you don't really need to factor out a 2 if there's nothing that's going to reduce. It's just hopefully you see, hey, these are all even numbers. I have a 2 on bottom that I could cancel potentially. Okay, so hopefully you guys see that you kind of do that. Don't write d dx equals. I know it does in my answer key. Hopefully I get those fixed in time for you guys. If not, just be careful. Make sure you're using this notation.
And remember that when it says d over dx of this, you could write equals here and start your derivative right here and then just work it down too. And that would be fine. Or just don't write anything once you take the derivative and just work vertically down. Okay, so last one for kind of this video. And then there's going to still be a whole nother video as the problems continue to get harder for chain rule or section 6.4. So this time, not only do we want to differentiate, but we're also going to have that operator notation where it says find dy over dx. So we keep trying to give you guys different examples with the different notation because that's what you're going to see when you're practicing and you're doing the homework, and that's also what you're going to have on your test. So our original rule is y equals x squared over the square root of 1 minus x. So because of the last two problems that we've done, I'm hoping that a lot of you go, okay, I'm going to have radical notation that's not really calculus friendly, and I'm going to change this in the denominator to be, notice I just still wrote y, I haven't taken the derivative of anything yet, x squared up top in the numerator over 1 minus x, the whole thing to the 1/2 power. And yes, you could move the quantity up and say it's 1 minus x to the negative 1/2, but it's not like I could just get rid of this. This isn't just a constant like it was before, like a 1. So actually there's not really an advantage to doing that. You guys, if this is a problem, we're going to have to bust out quotient rule on. It is a quadratic term, that's a single function, over a square root, because the 1/2 power is the same thing as a square root function on the bottom, and it's going to be quotient rule. You can't just take the derivative of the top and string it over the derivative of the bottom. That is totally wrong. That is 0 points. But with the quotient rule, you also are going to have chain rule embedded in it when you take the derivative of the denominator, because your bottom is a composition of functions. It's all of this linear function raised to the 1/2 power. So that's how the problems start to get more complicated. You might have product rule or quotient rule to start and chain rules embedded in one of the derivatives that you're taking, or you might have chain rule first and the inside has product rule or quotient rule. So it starts to get messy and the problems start taking you kind of like back when you were doing definition of derivative, like half a sheet, a 3/4 of a sheet of a piece of paper. So now that we're calculus friendly, my QR stands for, I'm going to take quotient rule. This is operator notation. I'm not just going to write y prime. They're telling me find the derivative of y with respect to x. I'm taking the derivative of both sides of my equation. So because I had something with both sides, like I can say this equals this, right? So the derivative of y with respect to x equals. Okay, so quotient rule. It's the bottom or the low function. Oh, that's the whole quantity, 1 minus x to the 1/2, times the derivative of the top, or times, right, d high. So the derivative of x squared is just 2x using the power rule.
I don't have video for
minus
because Ryan's finishing
big brackets, the top, x squared,
video
times the derivative of the bottom. So this is the part, you guys, where on the bottom function, right, or if you get stuck and you have to re-sing it, low d high minus high d low. The d low part, this is the inside, and the fact that we have it to the 1/2 power is the outside. So this is where the chain rule is going to come in.
Are you sure?
So we would take the derivative of the outside, bring the power down, leave the inside unchanged, decrease the power by 1, 1/2 minus 1 would turn into negative 1/2, and don't miss it, times the derivative of the inside. So see how I boxed that inside? So now I have to take the derivative of those two terms inside that red box. So the derivative of 1 is just a constant, goes to 0. The derivative of negative x would be negative
Just like
1, wouldn't
exponents
it?
and factoring.
Negative x is really like negative 1x. When I take the derivative using the power rule, this is to the first power. If I take the derivative with respect to x of this,
Alright.
I would bring the power down, I would multiply with the coefficient, I would decrease the power by 1. 1 minus 1 will go to x to the 0, but x to the 0, any
Oh, yeah.
base to the 0 power by definition is going to be 1.
Those were always
So wouldn't
fun.
it turn into negative 1? If it's a linear piece, it's going to drop to a constant. That's only one term, so I don't need any extra grouping symbols. All over the whole denominator, 1 minus x to the 1/2 power, the whole thing squared. Woo! Oh my goodness, this is intense, yeah? So there's the calculus step. Every other step
So
past
you want me
this
to try to
step
explain it through words?
is going to be
Maybe on
algebra
one of them,
cleanup.
or
So the derivative of y with respect to x, and
2a.
this again is kind of
Yeah,
where
it's gonna
there's
second
different
roll
philosophies
up
of how to clean it up. I don't know that there's like a perfect way, but I
Alright.
feel like you guys do best if you switch back to
So
radical
2a,
notation.
which is
So I would
on the product
flip
is
this
being
2x
multiplied
in
together.
front, because these are just multiplied
So
together.
we wanted
I put this in front, it's a monomial. A whole quantity to a positive 1/2 power is back in radical notation, the big square root of 1 minus x.
Yeah.
That's what I would do for that first part. Minus, I'm going to keep my big brackets, and I'm going to think about all of these as, like we've been doing on a lot of problems, individual fractions. This one's over 1, this one's over 1. Okay, so x squared's positive exponent, it stays on top.
The fractions together.
And 1 over 2, okay, the 2's on the bottom. This whole quantity is to a negative exponent, so doesn't that whole quantity need to reciprocate down? And now it's the base, the whole quantity 1 minus x, to the positive 1/2 power. This is a negative number, not a negative exponent. It stays on
Minus
top.
key is shown on 143
All
over 72.
over the bottom squared. Well, when I square, you guys, 1/2 squared, power to a power rule, wouldn't I multiply these
Oh,
exponents,
oh,
and
yeah.
1/2 times 2 would just be to the first power. So it's really just 1 minus x to the first power.
Oh yeah, yeah.
Oh, that's kind of
So
cool.
I just didn't write the
Okay,
final
so
answer on
moving
where I showed
up
my
here,
work. I just wrote the
dy
final answer
over
on
dx equals
I
2x times the square root of 1 minus x. Definitely make sure you keep things vertically up and down on your paper. Minus, well, this x squared times this negative 1 would turn into a negative x squared over
probably
the
not.
2. And I'm going to switch this back to radical notation, because now it's a positive 1/2 power. That's the same thing as the square root of 1 minus x. All
Oh, you'll be
over
fine.
the quantity 1 minus x, which I don't technically need parentheses around. I'm just kind of keeping them there to like help you realize it's 2 terms down in the denominator. Well, don't I have a fraction and a whole piece? And I'm trying to subtract. So don't I need a lowest common denominator? Don't I need an LCD? So my LCD, or my lowest common denominator, because this is just a 1, is going to be this guy's denominator. Oh, 2 times the square root of 1 minus x. So I need to multiply the first guy by that LCD. The other one already had it, but the first one does not have it.
That means we don't want to end up with a square root in the
So dy over dx equals this 2 times this 2
So you
would
really
turn
want to
into
reduce
4.
it as much as you possibly
The
can.
x would also
first.
be there. And is it the square
So,
root of 1
like,
minus x
that's an A.
times the square root of 1 minus x?
I'd look
It's the
at
square
that
root of
like
1 minus x times
50
itself.
over
Really
5
just 1 minus x.
reduced.
But isn't it this monomial times both of those 2 terms? Right? Over
Yep.
our LCD, 2 times the square root of 1 minus x. I think a lot of you are going to go, well, if I'm subtracting, but this
Yep,
is a
on top
negative,
and on
Miss
bottom.
Ryan, isn't that going to turn into a positive? And the answer to that is yes. So now it's going to be plus x squared, because this guy already had the LCD, over 2 times the square root of 1 minus x. Don't lose this 1 minus x.
How we would write
Which
it
is
as
still in
square
your
root of 2
denominator.
times the square root of 2.
So sorry that like there's background noise. Hernie's doing a little office hour with
Yeah.
his math 4. But this is our last example, so we wanted to get through it. Well, we get an LCD, so we can string the numerators together. So now don't I have all of the numerators strung together?
Oh, yep, yep.
4x times 1 minus x plus x
Nope,
squared
5 squares
over
two
the
is final
LCD.
answer.
2 times the square root of 1 minus x, all over the 1 minus x. Cool. Well,
Nice.
now I might want to clean things up a little bit, because up top in the numerator, I think if I distribute, I might have some like terms to collect. So if we distribute,
Okay, so let's look at like
we would get
7f
4x minus
Okay, so like your
4x
top
squared plus
is the
x
square root
squared
of mn.
over our
I would
LCD,
split that
2
up to
times the
be
square root
like
of
the
1 minus
square root
x.
of m
And I don't know if you guys see this or not,
times the square
but
root.
isn't this one fraction divided by one fraction if I put this
And
over
on
1?
bottom,
And if I have a single
would say
fraction
the
divided by a
square
single
root of m.
fraction, don't I want to do a little copy dot flip?
the
So
square
this
root
was
of
me
n
copying down the
squared,
first one, and I'm distributing too,
and
so I
then
can clean
times
some
square
things
root
up.
of p.
Times, this big division bar turns into the multiplication dot for times. The reciprocal, or to flip this over,
So it'd be-
would turn into 1 over 1 minus
because like now your
x.
m's will cancel.
Again, that's kind of why I was stringing the parentheses, because all of those two terms are down in
And
the
what's
denominator.
square root of n squared?
So, combining like terms, multiplying by 1 is not going to change anything. This is a linear term, there's no other linear terms to combine
Yep.
with, so that's going
Yeah,
to stay
like
4x.
Yeah, it's like
This is a negative
square root
4x
of
squared
n
and a
squared.
positive 1x squared. So these collect to give us negative 3x squared. All
Nope.
over
So your square root
The
of n
2
squared on bottom
times
doesn't
the square root
disappear,
of 1
it turns
minus
into a
x
normal n.
times the quantity 1 minus x. That would be an okay, acceptable version of the
So
answer.
our only square root on
A
bottom
lot of
now is
times
the square
people
root
will
of p.
see these match. What's underneath the radical and what's in this
So then
quantity
you
are the
just need to
same
multiply by
inside
the
piece,
top
the
and
1
bottom
minus x.
by the square root.
And really, if this is the same thing as to the 1/2 power, right? So I'm going to come up here. If 1 minus x, the square root is the same as 1/2 power, and I'm just focusing on the denominator
No,
for a minute, the
well,
2's still there,
But you have
but then I have
square
the
root
quantity
of p
1 minus
multiplied
x,
by
which is
square
to
root
the
of p.
first power.
So that's gonna make
These are really like
yeah, so it's
bases.
gonna make it
And when I
normal
have
now.
like bases, I add exponents. So 1/2 plus 1, 1/2 plus 2 halves would turn into 3 halves. So this would be okay, maybe a tiny bit better, or our answer could be 4x minus 3x squared over the
Yeah, but
2
the
in
n
front
on top are
times
inside
1
the
minus
square root,
x to the 3
and
halves
the n on
power.
bottom are not.
And I mean, unfortunately for you guys,
So
this
you
is
know
one
what
of those
you
times
have
where
to
I
use
have
is
all the
both
problems worked
these
out,
square roots.
and I would have you
Or
check
they're
your
both not
answers very
square root.
thoroughly. And in my answer key, at least, which I know is not on Hernie's website, I have like this answer or this answer, because one in this case is with rational exponents, and
Alright.
one is with radicals. And so there's kind of equivalent forms sometimes of the same answer that could be represented kind of the same way. So I mean, this problem took me a whole board. That's what I'm saying. Like, get ready for some problems that take you a half a piece to 3/4 piece to a whole full sheet of paper, depending on how big you write. That's kind of the end of 6.4, and there will be problems that
Alright,
take that
yeah.
much space too.
Just try a
When you
couple
guys go
of
to do your
those
test,
and
you
make sure
gotta
get them
do the
right.
homework.
Well,
Okay,
so
you
do
gotta
it.
practice. It's gonna be your last test of the year. All right, talk to you guys later.